We are Trevor Vera, Ryan Jacobs, Ricardo Gajardo, and Scott Davis. We are Team C, and we are Smart Parking Systems. Our project is a series of sensors that will help mitigate accidents in parking lots and parking garages. And they could also function as parking meters, so we would know how long someone has been taking up a certain spot. And we can use these sensors to tell how many spots are open in the parking garage or lot and on what floor before someone even turns into the parking garage. Our system is comprised of 5 sensors, 1 in the front and 2 on each side of the parking lanes. So you will know when you are approaching how close you are to the wall. It'll go from green to keep on going, red when to stop, and the 2 sensors on each side of the car on the lines are for when other cars are turning in. If they would collide with you on the side or if they would scratch your vehicle, a blue light would trigger, flashing on and off to tell them that they are too close, and now they'll know that they can back up and try to reposition themselves to fix it. I'm now going to pass over to Trevor Vera so he can go over the software involved in our project.
My name is Ryan Jacobs, and I'll be explaining the software database side of the parking lot sensor. To start off, we use the Ethernet shield to establish a MAC address here in the Arduino sketch. We set the IP address of each individual Arduino via the script or sketch, and then we set the server for the Raspberry Pi so it can update its status. Through that, we use the library for Ethernet and serial, and via a GET request we will send the IP address of each Arduino, the MAC address of each Arduino, and whether the space is occupied or not, to the main server, which is just a Raspberry Pi computer. If the connection is not made, we get a rejected, connection failed. And then the loop will wait 10 seconds before updating the status again. And then this is just a description of the table that we use to gather the information. Here's the database. It's got the ID, the identifier. MAC address is represented here, occupied spaces, and the IP address, as well as the start date from which you can gather other information. From there, we use a PHP script to pull the information.
At the rear, we have 3 sensors, and there will be a sensor on either end of the parking spot, as well as in the middle. At the front, well, I say at the top, there's going to be a green light that will signify if the spot is taken or not, a green or red light, and in the front there will be another green or red light. Depending on how close the car gets to a sensor that's up front, the sensor will be green to tell the driver to move forward, and then will turn red within 20 centimeters, telling the driver to stop. There's also a LED strip that goes around the parking space, and then this LED strip uses the 2 or the 3 sensors on the rear. If any of these detect that there is an object below it. Now that the system's active, I will demonstrate what makes our system a little different with the parking assist, as using these back 3 ultrasonic sensors. I'm going to use this rolling chair, roll it underneath each sensor, and each sensor will trigger the LEDs to flash. So at this time, I will be rolling the chair forward and placing it under the sensor for a few seconds. So I'll demonstrate it going under, and we'll leave it there. The lights will remain flashing until the object is no longer within that range. So I will pull the chair back out now, and as soon as I pull it out of that field, the sensor or the Arduino will tell the LEDs to quit flashing. So now I'll push it towards the middle sensor, and as soon as the field is broken, the LEDs will flash. They'll remain flashing as long as the chair is there. So now I'll pull the LED or the chair back out, and as soon as you pull the chair out, the sensor or the Arduino tells us the lights to quit flashing. And now the same thing for the last sensor right here. So I will push the chair forward, and once the field is broken, the LEDs will flash. So as long as this chair is within that, breaking that field, the lights will flash. So this is what the web server that is used with the Raspberry Pi will display at each floor, as well as the entry of every parking lot.
So as was just demonstrated, the smart parking system will give much value added to any large parking facility, such as an international airport or even a smaller downtown parking garage. The smart parking system's added accident avoidance will help assure drivers that they won't accidentally scrape the car next to them when they go to pull out of a tight spot. Not only that, but the Smart Network Hub will give an easy-to-understand assessment of all the vacant slots on each level. Even phone apps can be created and used with the Smart Parking System's hub to alert drivers ahead of time that the parking garage is full. This concludes the demonstration of the Smart Parking System. Thank you.